Lecture 7 is about inequalities, and these are very similar to equations, except the equal sign is replaced by one of these symbols: less than or equals, greater than or equals. Here's an example: 2x plus 1 less than or equal to 3 is an inequality. We're going to try to solve inequalities. So a solution to the inequality, or the solution to the inequality, is the set of all numbers which satisfy the inequality. And quite often this turns out to be represented by an interval, or perhaps even a number of intervals on the real line. The solution set to the inequality given above, 2x plus 1 less than or equal to 3, turns out to be the set of all x less than or equal to 1. And we'll see why this is true below. And this is the interval on the real line of all numbers to the left of 1, including 1. On the other hand, the solution to the equation 2x plus 1 equals 3 is just the unique value x equals 1. So there's a difference between the solution to this inequality and the solution to the equation, which looks very similar but is a very different kettle of fish. How do we solve inequalities? Well, we have algebraic rules for manipulating them, and they're very similar to the rules used to manipulate equalities, which we've used before to solve equalities. There are a couple of major differences, and that is in number 4 and 5 here in these rules. If I multiply both sides of an inequality by a number, a quantity less than 0, then I get an equivalent inequality when I flip the sign in the center. So if a is less than or equal to b and I multiply both sides by a quantity less than 0, then I get c of a is greater than or equal to c of b, and this is an equivalent inequality. And also if a is positive and b is positive and a is less than or equal to b, then 1 over a is greater than or equal to 1 over b. So we have to be careful when we're multiplying across by something which is negative, or when we're taking reciprocals. Now in all of these statements, I've used the inequality a less than or equal to b to start with, but all of them hold if that is replaced by less than, greater than, or greater than or equals, with the obvious changes on the right-hand side. For example, if I'm using a greater than b here, then multiplying, if I'm using a greater than b here in number 4, then multiplying both sides by a negative number should give me c of a less than c of b. Well, what are the rules? As with equalities, I can add the same quantity to both sides and I get an equivalent inequality. So if I have a less than or equal to b, I can add some quantity c to both sides. As long as I add the same quantity to both sides, the solution set of the inequality should remain exactly the same. If I subtract the same quantity from both sides, the solution set should also remain exactly the same. So a is less than or equal to b is the same as saying that a minus c is less than or equal to b minus c. I can multiply across by a positive quantity, and that doesn't change the inequality or the solution set to the inequality. So if a is less than or equal to b, and c is a positive quantity, then c of a is less than or equal to c of b, and vice versa. So the solution set to this inequality on the right is the same as that on the left. If c is a negative number, and this is the rule I warned you about, and I'm dealing with an inequality of the form a less than or equal to b, then when I multiply both sides by c, I get c of a greater than or equal to c of b. So this is an equivalent inequality to the one on the left, and I have to be careful to flip this sign in the middle when I multiply both sides by a negative number. If a is positive and b is positive and a is less than or equal to b, then 1 over a is greater than or equal to 1 over b. If you think of 2 and 3 here, you'll see why this is true. And if a is less than or equal to b and c is less than or equal to d, then a plus c is less than or equal to b plus d. In other words, I can add inequalities. Okay, so how would we solve the inequality 2x plus 1 less than or equal to 3? Well, I can eliminate this 1 by subtracting 1 from both sides, or I can cancel the 1 by subtracting 1 from both sides, and I get 2x plus 1 minus 1 on the left is less than or equal to 3 minus 1, and that gives me a new inequality. These 1's cancel, and I get 2x less than or equal to 2. Now, according to Rule 2, this is an equivalent inequality, so the solution set to this one is the same as the solution set to the original inequality. And now I can divide both sides by 2, and that's the same as multiplying by 1/2 on both sides, which is a positive number. So according to Rule 3, if I multiply by 1 over 2 on both sides, then I get 1/2 2 of x is less than or equal to 1/2 2 is equivalent to my previous inequality here. And now the 2's cancel there and the 2's cancel there, so I get x less than or equal to 1. And this is our solution set. This is one description. It's all real numbers less than or equal to 1. And another description we gave above on the real number line, it's all numbers on the number line which are to the left of 1, including 1. Let's try another example, and of course we'll get a little faster with the algebra as we move along. Suppose we're asked to solve the inequality 2x plus 1 less than or equal to 5x plus 10. This is slightly more difficult because it has x values on both sides. It's similar to the previous problem in that the highest value of x is 1, so it's a linear inequality. And now I can subtract 1 from both sides, and that's kind of the same as saying I'm bringing the 1 over to the right. Without changing the inequality here, I can just subtract the same number from both sides, which is 1. I get 2x plus 1 minus 1, that cancels. It's less than or equal to 5x plus 10 minus 1. When I tidy that up, I'm getting 2x less than or equal to 5x plus 9. Now, once again, I can apply rule number 2 to bring the 5x over to the left. And so I subtract 5x from both sides, and I get 2x minus 5x is less than or equal to 5x minus 5x, these two cancel, plus 9, or minus 3x is less than or equal to 9. So I have here an equality which is equivalent to the one I started with, but notice I brought all of the x's to one side and all of the constants to another. And this is a good strategy for solving linear inequalities. Bring all terms with x in them to the left and all terms which are constants to the right, and then tidy up, basically. So I'm now left with minus 3x less than or equal to 9. And of course this would be a solution set if it were of the form x less than or equal to something or x greater than or equal to something. So I'm going to try to transform it to an inequality of that form. And I do that by dividing across by minus 3. And that's the same as multiplying by minus 1 over 3. In other words, I'm going to cancel this minus 3. But now I have to be careful because this is applying rule 4, and I'm multiplying both sides by a negative number. So I get negative 1 over 3 times the left-hand side, and now the equality flips. That's greater than or equal to negative 1 over 3, the right-hand side, and that's because I'm multiplying by a negative number. Now all is well. This negative 1 over 3 cancels the negative 3, and I multiply on the right, and I get x is greater than or equal to negative 3. So my solution set here is everything on the number line to the right of negative 3. Here's one last linear inequality to solve. You might want to pause the video, try to solve that, and then have a look at the solution when you're done. Okay, so we have 5x minus 1 is greater than or equal to 10x minus 46. Sorry, that's not a 40, that should be 46. And now my strategy is to bring all of the constants to the right and all of the terms with x's in them to the left. And I can subtract 10x from both sides. And I can add 1 to both sides. And so that's minus 46 plus 1. And that's taking a shortcut basically here. Instead of writing plus 1 minus 1, I'm cancelling and adding to this side all in one move. Now I tidy up and I get minus 5x on the left is greater than or equal to minus 45. And dividing across by minus 5 is the same as multiplying by minus 1 over 5. And I'm not going to take shortcuts here because this is the tricky rule and this is the one that switches the sign. So I have to flip the greater than or equals to a less than or equals because I'm dividing both sides by a negative number. And now I get x, these two cancel, and x is less than or equal to the minuses cancel, and we have x is less than or equal to 9. And if you like number lines, that's everything to the left of 9 on the number line.